Hello everyone and welcome to today's Tech Talk. Learn how to use the XReact Grid with your React applications, hosted by Sentia. My name is Casey Crowder. I'm a Senior Marketing Manager here at Sentia and will be moderating today's webinar. I'm pleased to introduce today's presenter, Mark Bricado, Engineering Director at Sentia. He's been developing with XJS since version 2. Before coming to Sentia, he was the Director of R&D at Biofortis, a life sciences startup, where he led the development of several XJS apps. He is also the creator of Mockaroo.com, a web service for generating large data sets for software testing and demos. Before I hand the mic over to Mark to kick off the webinar, I'd like to take a moment to remind you all that this webinar is being recorded and will be available to view on demand on Sentia.com as well as on the BrightTalk platform. Additionally, we will host a Q&A session at the end of the presentation. If at any time during the webinar you have a question, please submit it via the Q&A panel of the BrightTalk interface. Mark, take it away.
Thank you very much, Casey. Again, my name is Mark Bricado, Engineering Director at Sentia. XReact, for those of you who don't know, is a library of over 100 React components. Things like grids, trees, charts, form controls, layouts, animations, visualizations, a whole bunch of stuff, both the form and the function of very sophisticated components targeting data-driven apps. So today we're going to talk about one of the most powerful components in the XReact library, and that's the grid. So we're going to do a lot of coding in this presentation. We're going to take you through starting with the basics of just getting a grid up and running, getting some data into it, defining your columns. Then we're going to dive into controlling what gets rendered in the grid cells, including embedding some components and charts in grid cells. We're going to go over exporting data to Excel, and as well as editing on multiple devices, so phone, tablet, and desktop. And then at the end, hopefully we'll have maybe 10 or 15 minutes for your questions, depending on how quickly I can get through things. Just an introduction to the grid and the overall architecture of how you use a grid. A grid in XReact is a data table that pulls in and renders data from a store. Store is not to be confused with the concept of a flux store. In XReact, our store implementation is a data structure that allows you to sort and filter data for something like a grid or a list, or several other components, things like charts within the XReact toolkit. And what makes the grid and the store a little bit different from the standard React approach is that the two are very tightly integrated. So typically a store, you can pass data directly to a store, or it can pull data on its own from a backend using a proxy. And so what this gives you is it means that you get all of this functionality, filtering, sorting, paging, grouping, summarization, all this interactive functionality with your grid without having to actually code it. So you can imagine if you were just coding up a grid using an HTML table or maybe another third-party component, you might have to do something like handle clicking on a column header to sort, or clicking on the divider between a column header to resize, or maybe sliding a pager and doing a fetch for the next page of data. Well, you don't have to do any of that coding with XReact. It's all built in because of the tight coupling between grid, store, and proxy in your backend. So we'll see a lot of that in action today. So without further ado, let's write some code. So I have an application here that I started using the XReact Yeoman template. It's just a basic React application that brings in the XReact library. Here is the main components in the application. It has one container at the root, which is marked as full screen, so it'll take up full screen. That's layout fit, which means it'll stretch its child to fill it. And we have one component that we're going to author here called a stocks grid. So we're going to make an example that shows information about stocks, equities, companies. So stocks grid is where we're going to start. And we have a example data set here called stocks.json. And it's a fairly large data set. I think I have something like 10,000 rows in this data set in JSON. And it's got, each one represents a company or a ticker symbol. So we have the name of the company, the ticker symbol, the sector, the industry that they're in, and then an array of ticks, which are basically the last 5 sales of that stock. So this is what we're going to display in our grid. And all of this data is basically meant to simulate something that would be returned by your backend. I'm just going to load it statically for now rather than go through all the mechanics of building an actual backend REST API. But it's going to be loaded in the exact same way that you would fetch from a real backend. So we can start by loading this data by creating a store. Again, grids always draw their data from a store, and some of the interactions with grids will trigger events on the store like reloading or sorting or paging. So to do that, we'll create our grid, or we'll create our store here, and I've got a few snippets saved in the IDE which will save me some typing and make sure I don't make any typos. So I'll use one of those now. So we're going to, in our constructor, create a store. It's going to have a proxy config. We could pass the data directly to the store if it was being passed out from a parent component in React, but having a proxy allows us to do all sorts of great things like remote paging and filtering and sorting. So we're going to do that because it's the most common use case. So this is an AJAX proxy, and it gets a URL. We set auto load to true so that it automatically loads when it's created. And the data isn't particularly sorted by anything, so we're going to have it sort on the client side by specifying the name property is what we're sorting by. So now that we've got our store, it's time to create our grid. And you can see above here, I've imported basically all the components that I'm going to need for today from the XReact library. So I'm going to start drawing from those now. So we're going to return a grid, and we assign it the store from this. And then what we're going to do is put columns in our grid. And so we use a column component, and it takes a data index. The data index is the name of the field. So we pop back to our data, we'll see, okay, we have a name field. Let's use that one first. And then it takes a text prop that is the column header text. So let's call this company name. And then we can also give it either a width, like a fixed width, or a flex, or a combination of flex and min or max width as well. So we're just going to be simple and say, I know this data looks good at about 300 pixels width, so we'll use that. And then I'll use a shortcut to add the rest of the columns in my grid. So we're going to pull in symbol, sector, and industry as well. And so now I'll save, and then if I bring up the results, here's that grid running in the app. And I have my Chrome debugger open just in case I type anything wrong. I'll see the errors there. So with that simple of a setup, there's not a lot of code there, we get a lot of features for free. For example, sorting. You can click on any column header and it'll automatically sort. In this case, it's sorting on the client side, but if I've implemented a real backend API, I could configure my proxy to do remote sorting so that it would call back to the backend and use like an order by clause in the database to do a sort. I also get resizable columns for free. So despite the fact that I set a width on each of these, if the user wanted to see something or close something down, they can do that just by dragging and resizing. And we also get a nice grouping feature too. So if I wanted to, let's say, group by industry, I can say group by this field, and it'll group all the data by the value of industry, and it gives you a pinned header as you scroll down for each of the groupings. So I'll turn that off. And then one last thing I want you to notice here is, I'll reload again. That's rendering pretty quickly for 10,000 records. Chances are you would never return 10,000 records at once to render in a grid, but I did it here just to show that you can do it. And the reason it renders so quickly is it's using what we call buffered rendering. So despite the fact that this table looks full and I can scroll down and it just keeps going and going and going, on initial load, it's not actually rendering all 10,000 records. That would take quite a bit. There'd be a lot of DOM elements there. So what it actually does underneath the hood is it renders just a little bit more than you're actually seeing in terms of the viewport height. And then as you scroll down, it's actually replacing the content of the cells with the newer records as you page down in the store. So it's actually conserving the DOM elements as much as possible. So it keeps the DOM small, keeps memory consumption small, and it keeps performance very high. And we'll see that later as we handle cell rendering. You can actually see that in action. Okay. So now let's take a look at controlling the styling of cells. So let's say we want to make this symbol column stand out a little bit more and make the symbols bold. The best way to do that is probably just using the cell prop. So cell takes a number of configs that control what the cell looks like. We'll throw a style config on there, and then we'll say font weight bold. And so here we have our bold symbols. Now that's probably the best way of doing it, but to illustrate another feature, I'm going to do this a different way. And that is, rather than put a style on the cell, I'm going to control the actual HTML elements that get rendered inside of it. So for that, I'm going to use a renderer. And so the renderer prop takes a function that returns React elements. And so this will get called for every row in your grid as it's rendered. So in this case, the renderer gets passed the value. So symbol, and we're going to return just a bold element, old-fashioned HTML with the symbol inside it. And there should be no difference here. It's going to render the same thing, but now we're actually using a bold tag. So that shows the simplest case of using a renderer. But now let's do something that's more applicable to the real world. And that is, let's say we wanted to have a button that we could click to buy one of these stocks on the column on the left-hand side. So in order to do that, we can add a column. And this time we're not going to use a data index because what we're doing doesn't really correspond to any particular item in the field or any field in the store. So this time we're just going to do a renderer. And we're going to create a function that's a member of this stocks grid component for the renderer. So let's say this dot render, we'll call it actions. This will be our actions column. Okay. So our function, is going to look like this. Render actions. So we're going to return XReact button instance. It's going to have the text buy, and it's going to, when you click it, call a handler, and we're going to pass in the record, which gets passed into us here in the renderer. So the renderer actually takes a number of arguments. The first would be the value, but since we don't have a data index here, it's not actually going to pass us a value. But the second argument is the full record, so we'll pass that along in the buy function that we're going to create. And then just some styling things. We're going to put a round UI on it so the button has a round look. And then this CSS class will prevent the row from being selected when you click on a button. So let's create our buy handler. That's going to be buy goals. So what we're going to do, just very simply, when you click the buy button, we're just going to use this function called exe.toast to display a little toast message at the top that says the symbol of the stock that you're buying. So again, we have our column. We're going to render for each row. We're going to render this button, and then when you click it, it's going to call this function. So there you can see it doing its toast. So you can see from this, you can basically embed any React component inside of a grid cell, and it's fully interactive, basically functions as a full React component. So let's do something even cooler. We have this array of ticks, the last 5 sales of the stock. Let's embed that as a sparkline chart inside the grid. The way that we do that is we'll have another column here, and this time we're going to pull from the ticks field. And this time we're going to create another renderer. Call it trend. Let's call our column trend. And there's a few other props that we want here. So that is sparkline column. So when we render our sparkline, we're going to have the grid force the width of the sparkline chart, so it takes up the full cell width, and then we're going to cancel any padding on that cell so we can take up as much space as possible with that sparkline chart. So let's go and render that. So here's our renderer. Render trend, we're going to return the sparkline chart, and it's going to take the ticks, which is the value of the data index packed in. So if we pass that array of points onto the sparkline line, we're giving it a height, and then as you mouse over the different points in the line graph, it'll display the Y value formatted as a number with 2 decimal places in a little tooltip so you can see what the values are. Okay, so let's give that a shot. So here's our little sparkline charts. And you can see, we still have this great performance of having all of this data, but without, suffering any real slowdown. And to illustrate again why that is, if we actually, let's go back to our actions render. If I put in a console.log here, where we just say render actions, we should get a bunch of that message coming to the Chrome debugger. And you'll see on initial load, despite the fact we have 10,000 rows, we're only seeing that function be called 39 times. And then as we scroll down, eventually we'll start to see it be called more. So it's delaying that rendering and buffering it, basically, so you're only seeing what's on the screen and it's not rendering a bunch of DOM elements off screen that would slow things down. Okay. So now we've got this nice grid displaying all the data that we want. Of course, one of the most common requirements anytime you put a grid on a screen in an application, especially an enterprise application, is you just want to be able to export that data to Excel. So XReact makes it really easy to do that. All we need to do is add a plugin to our grid. So we do that with the plugins prop, which takes an object where the keys are the names of the plugin and the value is just true, or you can also put them in an array as well. I have the plugin here, so that's grid exporter. And then in order to actually call the export function, we're going to put in some UI elements. We're going to put in a menu so you can select what the download format would be. So for that, we're going to use a few more components. One is title bar. Let's just call this grid stocks. And we're going to dock a title bar to the top of the grid. And then we're going to put a menu inside of it. So we have a button which we're going to align to the right. It's going to have a text export, and then when you click on the button, a little drop-down menu will appear with 2 options. You'll either be able to export to Excel or CSV. And so we have to create an export handler for this. It's going to pass along the type of format that we're exporting to and then just the extension for the file name. So let's implement that here. Again, we receive the type and the extension, and then this grid plugin adds this save document as method to the grid. So we're just going to call that, passing in the type, give it a file name, and that's going to spit out our Excel download. And so in order to get this.grid, we just have to add a ref to our grid. So that would be equal to grid equals grid. So when the grid is mounted, we're just going to get our reference to it. So now we have our export menu, and when I export this data to Excel, it's going to take a little while. It'll probably take like a second or two, just because there's 10,000 records in there. It's probably more than you would likely have in one page, but you'll see. Should spit that out. There we go. And, oh, hold on. So it actually popped off screen. I got this error message, because I always forget there's one thing you have to do when you export columns without values, like this action column. So it's telling me that the workbook is not good. The way you fix that is you can tell it to ignore certain columns when exporting. So for example, we're going to ignore export on the actions column, and then we're also going to just ignore the ticks as well. So now I export Excel. There it is, and there's my data. So pretty cool. If you ever need to export stuff to Excel or CSV or a bunch of different formats, you've got the data in a grid, you can add that export functionality just that quickly. You don't have to really code up anything yourself. Okay, so now we've got embedded components, we've got all of our formatting, we've got our export functionality. Now let's talk about actually editing data in this grid. So we can make this functionality a lot more like a spreadsheet by adding another plugin to our grid called Grid Cell Editing. So by adding this plugin and then marking certain columns as editable, so we're going to make our name editable, symbol, sector, and industry. Then if we go back, we should be able to double click and edit any of these columns. So let's maybe change this one to consumer goods. And then there you have it. So if we wanted to be able to do something special when you edit a cell, we have an event we can listen for. And the way that we do that is we actually listen on the store for a data change. So we do that by adding a listeners config and then listening for the update event. And then that's going to call this handler that we have to create. So our update event is going to pass a bunch of stuff. The store itself, the record that was updated, an object describing the operation that happened, so like the update in the actual fields. And then it passes an array of the field names that were actually changed. So we're going to use that again to just do something trivial like post the name of the stock that was changed and the field that was updated and the new value. I go back and repeat that change from before. You'll see it tells me that that record was changed. So that's how you could do something like listen for a change and flush it to the database, or update some other component in your application, or do whatever you need to. And I would say that for this one column, I don't want a text field. I want to control what the user can enter here. So I want something like a drop-down menu. So we can do that using another XReact component called a select field. So we just put that inside of the field that we want to edit. So in this case, I'm going to add a select field. And then we use the options prop on the select field to feed it the options for the dropdown. So I have that options here. So it's just an array of objects with text and values. So you could, get those from a store, or you could just have them passed in from the parent. Now when I refresh, and I double click, now I have a dropdown. So basically any form field you can embed inside a column for editing like this. Okay, so this works pretty well for a desktop experience, but as you minimize the screen and get down to like what might be a mobile phone experience, this might not be the best choice, at least for editing. Probably not the best choice for viewing as well. I probably want to slim down our grid or show a slightly different interface. But if you do have a grid on a small screen like this, you may choose to use a different editing style. So rather than have a pop-up like this, we can use a different plugin and only use it in a phone setting. So the way that we do that is using a special prop called platform config. So I'll add that here. And the way that platform config works, you can use this to set any prop to a different value based on platform. And here we're going to use it to use different plugins based on platform. So you give it basically the name of the platform or a negation of that name. And then inside of it is an object describing all the props that should be set when that platform is the one we're being served on. So in this case, for the desktop, we're going to use that same grid cell editing plugin as before. In fact, we can get rid of that. And when we're not on a desktop, so a tablet or a phone, we're going to use this other plugin called Grid Editable. And basically, it's going to allow us to edit an entire row in a pop-up. It gives us a little bit more room for displaying what the user needs to edit, and it's ideal for a mobile setting. So you may notice that we're defining the plugins prop here, and then we're defining more plugins here. The way the platform config works is it merges the props in here with the ones you define on the React element itself. So now, if I reload on a mobile device, if I double tap the row, then we get this slide-in sheet from the right that allows us to see the entire record as we edit. So it makes it a lot easier to use on a mobile device. And then also, you'll notice, despite the fact that we didn't change that select field, the interface that we get now for a select, since we're on a phone, is a typical phone-style picker rather than a drop-down. So you can override that, but by default, XReact is responsive when it creates certain form elements like this in terms of displaying things as a sheet that slides up from the bottom or as a pop-up, depending on the environment. And then if I go back to my desktop interface, you'll see that we still have the same old editing experience for desktop. So you get this really nice declarative way of configuring different props in different settings for different environments. And there's also a similar config called responsive config, which the keys there are screen dimensions rather than platforms. So you can make this kind of change based on the screen size rather than just the actual device that things are being loaded on. Okay, so if you're interested in going back and taking a look at this code for reference, I've shared it all on GitHub, and it is under Sencha XReact Grid Tech Talk. So basically, it's in the final state that I just showed now. And so with that, I'll take any questions that the crowd may have.
All right, thanks, Mark. Just a reminder for folks, if you've got questions, please do submit them using the Q&A panel. We do have a couple to start with, so let's go ahead and start there. First question, is there a more realistic example of a proxy connecting to a real back-end API?
Yes. So in this example, I just basically serve up this file statically. In fact, in my Webpack config, it's just being copied in using the copy Webpack plugin into the build directory. So that's not very realistic. But as part of the XJS Reactor repo, that is under, we go to GitHub and search for XJS Reactor. Hold on. I don't want to search this repository. XJS Reactor. There we go. This is the integration code that drives XReact, and it's all open source. And so it has a number of examples inside of it. And these are all linked from Sencha's website as well. But basically, this is implemented as a mono repo using Lerna. And so in the packages folder, in addition to the integration code, we have a bunch of examples. And the one you want to look at there is Reactor REST example. And I think you can also get to that from sencha.com if you go to XReact examples. Yeah, that's linked here, XReact REST example. So this actually shows you a real a node-based API on the back end that will hook up to a proxy on the front end. So here we basically implement one route. It's a grid of employees that you can filter and sort and page through. So this shows you what that API would look like if you were to implement it on your own on the back end. And it uses a SQLite database, and so it's much more realistic.
Okay, great. Thanks, Mark. We've got several other questions that just came in, so let's go to the next one. How does this grid compare in terms of functionality and performance with XJS4, Buffered Grid, and Tree Grid?
The performance of the old classic grid won't be nearly as good as the performance of this new XReact grid. So the XReact product is based on XJS Modern, which assumes modern browsers. So it's not trying to compensate for, like, Internet Explorer 6. So it's much lighter on the DOM, and thus the performance is quite a bit better. I'm not sure, but if I remember correctly, back in ext4, buffered rendering either wasn't there or wasn't the default, but buffered rendering is now your default for all grids. And so you get that improvement as well. As far as the functionality, it's almost all of the functionality of the old classic grid. There's a few things that are still missing that we're slating for the next minor release of XReact. Notably, I think one of them is being able to drag columns to reorder, but that should be coming this summer. And I think there's a few other things as well, but for the most part, all of the functionality is there, but with significantly better performance. And the tree grid, so in XReact, tree is really just a column type. So you can put a tree column in any grid to get the functionality of either just a regular old tree or a multi-column tree as a grid.
All right, great. I think this is a follow-on question. What about performance? Is it any faster than without React?
Is it any faster than without React? I would say that React here isn't speeding things up, if I interpret the questions correctly. But I would venture to say that this implementation of Grid, for the reasons I explained, is likely to be a lot faster than many other React grids. Because of the buffered rendering, because of the tight integration with stores, it really does maximize the performance in terms of minimizing DOM churn and still giving you features like paging and sorting with the tight integration with stores. So I believe this should be the best performing grid out there for big data sets especially. And you saw that the size of the data set that I loaded there. Very rarely you're going to load 10,000 records in a single page at once. And it was basically taking no time at all. So you could probably go a few orders of magnitude bigger than that before you'd start to notice a client-side issue. But again, you're probably only loading 50 to 100 records a page anyway in most settings. So I think the performance is very strong.
Great. Next question. What about rendering React elements in a row expander?
So you can definitely do that. I think a row expander, I forget exactly how it works, but it either has a template config that takes that same type of renderer function, or it has a renderer function. There is an example, I think, coming out with the next version of Kitchen Sink, which should be out in another week or so, that I think does just that. But yeah, you can render components inside a row expander. The one shortcoming that's been pointed out to us most recently with the row expander is that those aren't lazy loaded in that when you expand a row, the component is already there. It's already rendered before you expand. And we have a ticket in, I believe, for 6.6, so the next minor release, to make that lazy loaded so that the component will only render when you actually expand the row. So that'll open up a whole new set of improved performance for that particular component. But yeah, you can put React components inside a row expander.
Okay. Next question. Is the export functionality all done client-side? No back-end calls needed?
Yeah, it's all done client-side in terms of actually writing the Excel spreadsheet. The only back-end call that you might need is you might want to fetch more data. Like, for instance, if you wanted your functionality to be, I'm looking at a page, but when I want to download the entire matching data set, then you want to actually do a fetch to get that whole data onto the client so that it can be put in the Excel spreadsheet. But in terms of actually building the spreadsheet, yeah, that's all client-side. So everything you need is exactly what I showed there. There's no trick up my sleeve. It's just add the plugin, and then it looks at what's in the store and it renders it to a Excel spreadsheet. Or there's other formats, for example, CSV, I think time delimited, and then a few different choices with Excel as well as to which year of Excel you want to be compatible with.
Okay. All right, and next question. How does the XReact store compare to a store in Flux?
Okay, so the two are not to be confused. The term store is actually a holdover from XJS, but they really don't, they're not to be compared. You probably wind up putting your store in a Flux store. And I actually wrote a blog article attempting to clear up this confusion a few weeks ago. So if you go on the Sentia.com blogs, you'll see my article about our store versus a Flux store. And that goes into depth as to how you would want to orient the two with respect to one another. Typically, you'd either put the store, put the XReact store in your Flux store to hold the data, or you would just put the store in the wrapping components, like in this case, the DocScript component. And your Flux store would just hold things like the filtering criteria, maybe the URL for the store, simpler data. So you'll wind up using both in combination generally. And many times you'll just wind up hiding the fact that a component uses a store by having that component manage the store itself and get its data, like things like criteria, the column to sort by, other things passed in as simple props from the parent.
All right, great. Well, it looks like we've answered all the questions that were asked at this time. So, Mark, I want to thank you for the great presentation and in-depth Q&A. I'd also like to remind everyone today that the webinar was recorded, and you'll be receiving a follow-up email with a link to the recording shortly. Once again, thank you all for attending today's webinar, and we look forward to you joining us next time.
Okay, thank you very much, guys.